The afternoon sun blazed mercilessly over the Dutch countryside. 14,000 feet above Eindhoven, the sky filled with aircraft. September 17, 1944, would witness military history's largest airborne assault. Operation Market Garden was unfolding below in all its ambitious complexity. Among the countless Allied warplanes supporting the massive paratrooper drops, formations of Republic P-47 Thunderbolts circled menacingly. Their wings sagged under loads that would have been unthinkable mere months before. German pilots, scrambling desperately to intercept these formations, couldn't believe what they were seeing. These same bulky American fighters that they had mocked and dismissed now carried explosive payloads weighing 2,500 pounds. The bomb load represented exactly half of what a mighty B-17 Flying Fortress typically carried on its grueling long-range bombing missions. For Luftwaffe pilots who had spent 2 years learning to counter American air tactics, this sight represented something impossible. The evolution defied every assumption they had made about American aircraft design philosophy. Here was a fighter they had written off in 1943 as hopelessly overweight and ungainly for serious air combat. Yet it had transformed into something that shattered their most basic understanding of aerial warfare principles. A single pilot flying a single-engine aircraft could now fight through enemy defenses to reach a target. Once there, he could deliver destruction equivalent to a light bomber. Then he could fight his way back to base through whatever opposition remained. The metamorphosis of the P-47 from simple interceptor role into the most devastating fighter-bomber operating in the European theater would reshape more than just battle tactics. This transformation would speed the Wehrmacht's final collapse. It would revolutionize military aviation doctrine for generations to come. What German strategists never anticipated was that American industrial pragmatism had created something unprecedented. Not merely a fighter aircraft, not simply a bomber, something entirely different. Here was a universal combat platform capable of performing virtually any mission at any time. The effectiveness would prove absolutely devastating to German war efforts. When Republic P-47 Thunderbolts first entered combat during April 1943, they seemed to validate every German prejudice about American aircraft engineering approaches. The machines appeared big, heavy, and brutally powerful. Yet they clearly lacked the elegant finesse that German engineers prized above all else. The 4th Fighter Group conducted the type's inaugural official combat mission on April 8, 1943. German intelligence analysts studying captured photographs and pilot reports of this new American fighter reached entirely predictable conclusions. The raw technical specifications alone suggested mediocrity at best. Each P-47 weighed 10,000 pounds when empty. This represented double the weight of a nimble Messerschmitt Bf-109G. The massive Pratt & Whitney R-2800 double-wasp power plant driving each aircraft was an engineering marvel in its own right. This 18-cylinder radial engine initially produced 2,000 horsepower. Later variants would eventually achieve 2,300 horsepower output. The most advanced models would ultimately reach 2,800 horsepower. Yet all this power had to propel an aircraft that appeared designed by engineers who had never heard the word streamlining. Initial combat encounters seemed to reinforce every German assumption about American design philosophy. The P-47's early combat radius extended only 125 miles from base. This severe limitation drastically restricted its effectiveness when escorting heavy bomber formations deep into German territory. Its rate of climb lagged noticeably behind contemporary German fighter designs. During turning engagements at medium altitudes, both the Focke-Wulf 190 and the Messerschmitt Bf-109 maintained clear tactical advantages. German pilots rapidly developed specific tactics designed to exploit these apparent weaknesses. They would force the heavy American fighters into tight turning battles. They would initiate vertical maneuvering contests where the P-47's excessive weight became a serious liability. What Luftwaffe technical experts completely failed to comprehend was that they were observing an aircraft still in its developmental infancy. The machine had been designed with capabilities that wouldn't be fully exploited for another full year of warfare. The robust construction methods that made each P-47 so heavy were built around steel tube frameworks and extensive armor plating. This same construction philosophy also enabled each aircraft to absorb tremendous battle damage. More importantly, it allowed the airframe to carry extraordinary external loads that would tear the wings off most contemporary fighter designs. The wing mounting points originally designed for simple drop tanks to extend operational range had been engineered with remarkable strength margins. These attachment points could actually support up to 2,500 pounds of various ordnance configurations. Such a load would have literally destroyed the wing structure of most other fighter aircraft then in service. The P-47's transformation from pure fighter to devastating fighter-bomber began not with grand strategic planning, but through purely pragmatic field adaptations. As 1943 progressed steadily toward winter, P-47 pilots returning from routine bomber escort missions began engaging targets of opportunity during their return flights. Railway locomotives became favorite targets. German supply convoys proved irresistible. Fuel storage depots offered tempting destruction possibilities. The initial results proved immediately and dramatically promising for Allied tactical aviation. 8 Browning M2 50-caliber machine guns mounted in each P-47's wings created devastating firepower. Each gun fired 800 rounds per minute when the trigger was depressed. Together, they could deliver 12.7 pounds of lead projectiles every second of sustained firing. This concentration of firepower proved sufficient to tear completely through a locomotive's boiler. It could shred an entire truck convoy in a single strafing pass. The first official bomb-carrying modifications were implemented during November 1943. Army Air Force engineers installed specialized bomb shackles rated for 500-pound bombs. These were mounted on both the belly centerline and wing pylons. November 25, 1943, marked a historic milestone in tactical aviation. The 62nd Fighter Squadron conducted the first official P-47 bombing mission against a legitimate military target. 8 Thunderbolts attacked the Luftwaffe airfield at Saint-Omer, France. Each aircraft carried 2 250-pound bombs beneath its wings. The mission successfully destroyed 2 large aircraft hangars. 5 German aircraft parked on the ground suffered significant damage. The winter months of 1943 through 1944 saw Republic Aviation and USAF Technical Services dramatically accelerate the P-47's ongoing transformation. Engineers systematically reinforced wing spars to handle asymmetric loading conditions. These occurred when only one bomb was successfully dropped during an attack run. They developed entirely new electrical systems specifically for bomb release mechanisms. These systems had to function reliably at altitudes up to 30,000 feet, or during treetop-level attacks. Specialized gun sights were created for this new bombing role. The K-14 computing gun sight represented cutting-edge technology. It could automatically calculate proper bombing angles for both dive attacks and shallow glide bombing approaches. By early 1944, the modifications had progressed far beyond simple bomb mounting racks. The M8 4.5-inch rockets gave each P-47 the explosive firepower equivalent to a naval destroyer's main battery. Each rocket packed the destructive punch of a 105mm artillery shell. A single Thunderbolt could carry 10 rockets plus 2 1,000-pound bombs simultaneously. This represented more explosive power than many twin-engine bombers had carried early in the war. June 6, 1944, marked D-Day, and the moment when the Luftwaffe finally grasped what the P-47 had actually become. During that single day of intense combat operations, P-47s flew 1985 individual sorties. They dropped 525 tons of bombs on German defensive positions. They fired 35,000 rounds of 50-caliber ammunition at ground targets. The destruction they accomplished was staggering in its scope and precision. 86 locomotives were completely destroyed. 507 motor vehicles were eliminated. 38 artillery gun positions were knocked out. 17 fuel storage dumps were obliterated. The aircraft that German strategists had initially categorized as a mediocre high-altitude interceptor had evolved into the primary workhorse of Allied tactical air power. Luftwaffe pilot Günther Röhl stood among history's highest-scoring fighter aces. His final tally reached 275 confirmed aerial victories. He encountered P-47 formations repeatedly throughout 1944. A 1996 interview with HistoryNet captured his professional assessment. The P-47, which shot me down, we recognized immediately. It possessed tremendous diving speed capability. It could reach 1,400 kilometers per hour in a steep dive. The Bf-109 was limited to only 1,000 kilometers per hour maximum. I learned this lesson quickly when American pilots chased me. I could do absolutely nothing to escape their pursuit. May 12, 1944, proved to be Röhl's unlucky day. P-47s from the 56th Fighter Group shot him down during aerial combat. He lost his left thumb in the engagement. His damaged flying glove remains on display at the National Air and Space Museum in Washington. After Germany's surrender, Röhl flew captured P-47s extensively. The German fighter leaders' school used him to evaluate Allied aircraft capabilities. He accumulated approximately 300 flight hours in various P-47 variants. The P-47's ability to transform instantly from bomber configuration to pure fighter created an impossible tactical problem for the Luftwaffe. German fighters sent up to intercept what appeared to be vulnerable fighter bombers would suddenly find themselves in deadly aerial combat. These same aircraft had just jettisoned their bomb loads and reverted to pure fighters. They possessed superior firepower and remarkable structural durability compared to German designs. The mathematics of P-47 payload capacity created logistical nightmares for German supply systems. A standard P-47 D-25 could carry multiple bomb configurations depending on mission requirements. Two 1,000-pound bombs represented maximum load. Three 500-pound bombs offered medium payload flexibility. Various combinations of bombs and rockets could total 2,500 pounds maximum. This represented exactly 62.5% of a B-17's typical 4,000-pound operational load on long-range strategic bombing missions. The comparison was a reasonable approximation of half a flying fortress bomb load. A complete squadron of 16 P-47s could deliver 32,000 pounds of bombs in a single mission. This equaled 8 B-17 heavy bombers operating at typical combat loads. But unlike heavy bombers that flew from English bases perhaps twice weekly, P-47s could fly 3 complete missions daily from forward airfields in France. A single P-47 squadron could theoretically deliver more explosive tonnage in one day than a heavy bomber squadron delivered in an entire week of operations. The efficiency differential was absolutely stark when analyzed mathematically. One P-47 with 2,500 pounds of bombs required only one pilot and minimal ground crew support. One B-17 with 4,000 pounds of bombs required 10 aircrew members plus specialized ground support personnel. The fighter-bomber delivered significant destructive power using only a fraction of the manpower investment. August 1944 brought the P-47's most devastating demonstration of fighter-bomber effectiveness. The Falaise pocket operation trapped large German forces attempting to escape Allied encirclement. Between August 12th and August 21st, these forces faced continuous attack from P-47s, operating in organized shifts from dawn until dusk. The authenticated kill claims from Falaise were later verified through systematic ground reconnaissance. August 13th saw 112 tanks confirmed completely destroyed. August 14th brought 287 motor vehicles confirmed destroyed. August 15th recorded 42 locomotives confirmed destroyed. August 16th witnessed 89 horse-drawn vehicles destroyed. The 9th Air Force's P-47 groups operated using a carefully coordinated relay system. Fresh squadrons would arrive as others departed to rearm and refuel at forward bases. This maintained absolutely constant pressure on German forces attempting any daylight movement whatsoever. Post-battle analysis conducted by Allied intelligence revealed that approximately one-third of all German vehicles destroyed in the pocket were victims of air attack. P-47s accounted for the clear majority of these confirmed kills. September 1944 brought widespread deployment of the 5-inch high-velocity aircraft rocket throughout P-47 squadrons. HVAR transformed P-47s into highly effective tank destroyers. Each HVAR carried a 60-pound warhead capable of penetrating the armor of any German tank design. This included the formidable Tiger and Panther heavy tanks that had dominated ground combat. A single P-47 could carry 10 HVARs simultaneously. This delivered the equivalent destructive power of an entire artillery battalion barrage in one attack pass. The 362nd Fighter Group pioneered systematic rocket attacks against German armored formations. Their detailed after-action reports documented the precise technique. Pilots would dive from 5,000 feet at a 30-degree angle. They released rockets at 1,500 feet altitude. Direct hits were achieved on 30 to 40% of all rockets launched. This far exceeded the accuracy rates achieved by conventional artillery batteries. December 1944's Battle of the Bulge demonstrated the P-47's evolution into a truly all-weather fighter-bomber platform. Despite freezing fog and heavy snow that grounded most other aircraft types, P-47s continued operations. They were equipped with British-developed rocket rails and significantly improved instrument packages. When weather conditions briefly cleared on December 23rd, P-47s flew 647 sorties in a single day. They claimed over 400 vehicles destroyed during these intense operations. The statistics from December 23rd through 27, 1944 revealed the P-47's devastating impact on German mobility. 101 German tanks were confirmed destroyed. 1,930 motor vehicles were destroyed. 953 horse-drawn vehicles were destroyed. 89 locomotives were destroyed. 512 rail cars were destroyed. 47 bridges were damaged or completely destroyed. January 1945 revealed yet another P-47 capability that German engineers never anticipated. Precision bridge destruction using 1,000-pound bombs became a specialty mission. The 56th Fighter Group developed specific techniques for destroying railroad bridges that had survived previous heavy bomber attacks. 8 P-47s could deliver bombs with 50-foot accuracy during 60-degree diving attacks. This far exceeded the precision achievable by high-altitude heavy bombers. Those formations were considered fortunate to hit within 1,000 feet of their intended target. The deployment of the revolutionary Me-262 jet fighter during early 1945 should theoretically have changed everything. With a 100-mile-per-hour speed advantage over P-47s, the jet seemed completely immune to conventional interception. But the P-47's evolution into an effective fighter bomber created an unexpected vulnerability for German jet operations. Me-262s required long concrete runways for safe takeoff and landing operations. They consumed aviation fuel at absolutely prodigious rates. Their specialized bases became primary targets for P-47 fighter-bomber attacks. March 21, 1945, saw P-47s of the 365th Fighter Group catch JG-7's Me-262s during vulnerable takeoff operations. The jets were accelerating down the runway at Leipheim Airfield. They couldn't maneuver effectively or achieve the speed necessary to escape attacking P-47s. 8 Me-262s were destroyed in just 5 minutes of combat. This exceeded German jet production capacity for an entire week. March 1945's Operation Clarion involved systematic destruction of the entire German transportation network by fighter bombers. P-47s were assigned specific sectors with explicit orders to destroy anything that moved or could potentially move. March 22 alone saw P-47s claim 89 locomotives destroyed. 126 rail cars were destroyed. 155 motor vehicles were destroyed. 17 bridges were completely dropped. 93 rail cuts severed transportation lines. The P-47's transformation required absolutely continuous innovation throughout its service life. The P-47 D2E5, introduced during mid-1944, featured significantly reinforced wings. These were stressed for 3,000-pound external loads. Universal bomb shackles accepted both British and American ordnance types. Zero-length rocket launchers reduced aerodynamic drag substantially. Improved oil cooling systems enabled extended low-altitude operations. Paddle blade propellers provided better acceleration characteristics. Water injection systems boosted engine power to 2,800 horsepower. The K-14 computing gun sight enabled accurate bombing runs. Republic Aviation's Farmingdale and Evansville manufacturing plants demonstrated remarkable production flexibility throughout the war. Peak production reached 35 P-47s completed daily. 28 major variants were produced simultaneously. 430 different field modification kits were developed. The plants maintained continuous production for 48 months without ever stopping for major redesign work. This manufacturing feat remained unmatched by any other fighter aircraft manufacturer during the war. Training P-47 pilots required revolutionary approaches to transform fighter specialists into multi-role combat aviators. The USAAF established comprehensive programs requiring 200 flight hours minimum before any combat assignment. This included 50 practice bombing runs against ground targets, 20 rocket firing passes using live ordnance, 100 strafing runs against various targets, 40 hours of instrument flying in all weather conditions, 30 hours of tight formation flying. This comprehensive training approach contrasted sharply with late-war Luftwaffe pilot preparation. German training had declined to just 110 flight hours before combat assignment. German fighter pilots received absolutely no fighter-bomber training whatsoever. American pilots demonstrated competence across multiple roles: high-altitude bomber escort missions, medium-altitude air combat engagements, low-level navigation in enemy territory, dive bombing against pinpoint targets, skip bombing against bridges and ships, glide bombing for area targets, rocket firing against armor and vehicles, napalm delivery against fortified positions, ground strafing against opportunity targets. They could transition seamlessly between these roles as individual missions demanded. February 1945 introduced napalm bombs carried by P-47s in combat operations. Standard 150-gallon drop tanks were filled with jellied gasoline. These created weapons capable of incinerating entire city blocks or forest defensive positions. The 362nd Fighter Group first employed napalm operationally on February 14, 1945. Their target was a Wehrmacht supply depot hidden deep in Reichswald forest. 8 P-47s each carried one napalm tank and one 500-pound conventional bomb. The resulting firestorm was visible from 20 miles away. 3 acres of carefully concealed supplies were destroyed within minutes. March through May 1945 witnessed the P-47 at its absolute evolutionary peak. The P-47M variant, capable of 470 miles per hour, entered frontline service. Its performance matched early jet aircraft in many respects. The P-47N, designed specifically for Pacific operations, demonstrated 2,350-mile range while carrying bombs. But tactical employment truly revolutionized modern warfare concepts. P-47s operated as forward air controllers, directing other aircraft to targets. They served as artillery spotters for ground forces. They functioned as photo reconnaissance platforms. They acted as communication relays between separated units. They delivered psychological warfare materials, including propaganda leaflets. They provided emergency supply delivery to surrounded friendly units. The same basic aircraft type could perform 6 completely different mission types within a single day of operations. The comprehensive statistics of P-47 operations throughout the war clearly define the revolution it represented. Total production reached 15,683 P-47s built. This made it the most produced American fighter of the entire war. Republic's Farmingdale plant produced 9682 aircraft. Republic's Evansville plant produced 6242 aircraft. Curtiss-Wright's Buffalo plant contributed 354 aircraft. Republic's daily production peaked at 35 aircraft completed. Unit costs were reduced from $15,594 in 1942 to $83,001 by 1945. Combat operations generated truly staggering statistics. Total sorties flown exceeded 6,000 individual missions. Combat losses totaled 3,499 aircraft. Loss rate per sortie averaged just 0.7%. Air-to-air kill ratio reached 4.6 to 1 in P-47 favor. Total ordnance delivered included 13,200 tons of bombs dropped, 13,500 rockets fired at ground targets, 119 million rounds of .50 caliber ammunition expended. Confirmed destruction in the European theater was equally impressive. Enemy aircraft destroyed in air combat totaled 3,916. Enemy aircraft destroyed on the ground reached 3,202. Locomotives destroyed numbered 9,000. Railway cars destroyed totaled 86,000. Motor vehicles destroyed reached 68,000. Armored vehicles destroyed numbered 6,000. Horse-drawn vehicles destroyed totaled 6,000. The P-47's evolution fundamentally changed basic military strategy throughout the world. Pre-war doctrine had rigidly separated strategic and tactical air power into distinct categories. Heavy bombers were designated for strategic targets only. Fighters existed solely for air superiority missions. Attack aircraft were specialized for ground support roles exclusively. The P-47 completely merged these previously separate roles. It achieved genuine strategic effects through purely tactical means. The systematic destruction of transportation infrastructure by P-47s accomplished objectives that years of strategic bombing had struggled to achieve. By April 1945, German forces couldn't move during daylight hours anywhere. Supply lines ceased functioning effectively. Reinforcements couldn't reach the front lines. The tactical had genuinely become strategic through sheer accumulated destructive effect. Strategic bombing survey analysis after the war revealed that fighter-bomber operations conducted primarily by P-47s had reduced German rail traffic by 75% in forward combat areas by March 1945. This transportation paralysis contributed more significantly to ultimate German defeat than the destruction of industrial targets by heavy bomber formations. The P-47's remarkable success forced fundamental changes in military doctrine worldwide. The U.S. Air Force's first official doctrine manual, published in 1947, stated clearly that the artificial distinction between fighter and attack aircraft had been rendered completely obsolete. All fighters must be capable of effective ground attack. All attack aircraft must be capable of adequate self-defense. This represented a complete reversal of pre-war military thinking. The 1935 Army Air Corps manual had stated that pursuit aviation's sole purpose was achieving air superiority through aerial combat exclusively. Diversion to other roles weakened this primary mission significantly. The P-47 proved decisively that mission flexibility actually multiplied overall combat power exponentially. A fighter that could only fight was exactly half as valuable as one that could fight and bomb effectively. This fundamental lesson shaped every subsequent American fighter design. The P-47's revolutionary concept proved so influential that it shaped post-war aircraft design philosophy globally. When the Korean War began during 1950, the P-47's direct descendants dominated tactical air warfare. F-84 Thunderjets and F-86 Sabres, configured as fighter bombers, carried forward the basic concept. The multi-role fighter concept pioneered by the P-47 had become completely standard doctrine. Republic Aviation's transformation of the P-47 represented American industrial capability at its absolute peak. The company's founder, Alexander Kartveli, had designed the aircraft with exceptional structural strength margins built in. The Army Air Force had requested a 6G-capable aircraft design. Kartveli built one stressed for 12G loading. They wanted 500-pound bomb-carrying capability. He provided structure capable of supporting 2,500 pounds. This deliberate over-engineering allowed rapid field modifications that transformed the aircraft's capabilities faster than formal design changes could be implemented. The P-47, leaving Republic's production plants in 1945, incorporated hundreds of improvements derived directly from combat experience. Yet production never stopped for major redesign work. The production statistics revealed the complete industrial miracle. 48 months of absolutely continuous production. 15 683 aircraft delivered to combat units. 28 major variants produced. 430 field modification kits developed. Peak production of 35 aircraft daily. 2 complete plants operating simultaneously. Cost reduction of 27% despite massive capability increases. The P-47's fighter-bomber concept directly influenced every subsequent combat aircraft design program. Direct descendants included the F-84 Thunderjet, which was essentially a jet-powered continuation of the P-47 concept. The A-10 Thunderbolt Tsetsaku was named explicitly after the P-47 and carries the ground attack mission forward. The F-105 Thunderchief was a strategic fighter bomber extending P-47 philosophy. Conceptual inheritors included the F-4 Phantom II, where multi-role capability was central to the basic design. The F-16 Fighting Falcon was a lightweight fighter that evolved into a premier fighter bomber. The F-15E Strike Eagle was an air superiority fighter adapted for strike missions. The F-18 Hornet featured dual-role fighter attack capability from initial conception. The F-35 Lightning II Toulouse represents the ultimate multi-role aircraft, replacing multiple specialized types. The P-47 established the fundamental template for all these designs. Build strong, build adaptable, let operational requirements drive capability evolution naturally. The comprehensive training program developed specifically for P-47 fighter-bomber pilots established professional standards still followed today. Modern fighter pilots receive training for air-to-air combat missions. They learn air-to-ground attack techniques. They master reconnaissance procedures. They study electronic warfare applications. This multi-role approach was pioneered by P-47 squadrons. The 200-hour pre-combat training requirement established for P-47 pilots became the baseline standard for post-war air forces globally. The emphasis on instrument flying proficiency, formation tactics mastery, weapons delivery accuracy. These established professional standards that defined modern military aviation. Luftwaffe veterans' post-war assessments consistently identified the P-47 fighter bomber as a decisive factor in Germany's ultimate defeat. Authenticated testimony from Gunther Roll provides crucial historical insight. He flew captured P-47s extensively after Germany's surrender. His 1996 HistoryNet interview praised the aircraft's exceptional comfort level. He noted its remarkable reliability. He emphasized its incredible versatility. He mentioned particularly that the engine had no oil leaks whatsoever. This contrasted sharply with German aircraft designs. Statistical analysis completely supports veteran testimony from both sides. By war's end, the Luftwaffe could muster only about 100 operational fighters on any given day. This wasn't from lack of aircraft production. It resulted from lack of aviation fuel. It stemmed from destroyed airfields. It came from logistics systems completely paralyzed by P-47 attacks. The fighter bomber had achieved what strategic bombing alone couldn't accomplish: complete paralysis of enemy military operations. The P-47's fighter bomber capability provided extraordinary economic efficiency compared to traditional strategic bombing approaches. Cost per ton of bombs successfully delivered varied dramatically between aircraft types. B-17 Flying Fortress operations cost $28,000 per ton. B-24 Liberator operations cost $24,000 per ton. P-47 Thunderbolt operations cost only $4,200 per ton. Crew losses per 100 tons delivered showed similar dramatic differences. B-17 operations lost 8.5 aircraft per 100 tons. B-24 operations lost 7.2 aircraft per 100 tons. P-47 operations lost only 0.9 pilots per 100 tons. Support requirements per ton delivered showed the same pattern. B-17 operations required 47 ground personnel per ton. P-47 operations required only 8 ground personnel per ton. The mathematics were absolutely undeniable. P-47s delivered equivalent destruction at 15% of the cost and 10% of the manpower investment required by heavy bombers. The transformation of the P-47 from pure fighter to fighter bomber carrying half a B-17's operational bomb load represents far more than simple tactical evolution. It embodies the distinctly American military genius for pragmatic adaptation under combat conditions. The Luftwaffe never expected this transformation because it violated their most fundamental understanding of specialized military equipment design philosophy. German military doctrine emphasized absolute perfection within narrowly defined roles. The best possible fighter design, the best possible bomber design, the best possible attack aircraft design. American doctrine, shaped by industrial pragmatism, emphasized adaptability and operational efficiency above theoretical perfection. The P-47 proved decisively that in modern warfare, flexibility beats specialization every time. When Luftwaffe pilots encountered P-47 formations over Eindhoven on September 17, 1944, they faced not just another aircraft type, but a complete revolution in military thinking. Those same heavy, clumsy interceptors they had dismissed contemptuously in 1943 had become the primary instruments of their destruction. Not through superior performance in any single specialized role, but through absolutely unprecedented versatility across multiple mission types. The P-47's comprehensive combat record, in the European theater from 1943 to 1945, stands as one of the most successful in aviation history. Aircraft performance figures tell part of the story. Maximum speed reached 433 miles per hour in the P-47D variant. Maximum speed reached 470 miles per hour in the P-47M variant. Combat radius extended 450 miles with external drop tanks. Service ceiling reached 43,000 feet altitude. Maximum bomb load totaled 2,500 pounds. Production excellence statistics complete the picture. Total aircraft built reached 15,603 units. Monthly peak production reached 150 aircraft. Manufacturing costs were reduced 27% over the entire production run. Variants produced totaled 28 different types. Field modifications exceeded 430 different kits. Combat effectiveness statistics demonstrate the real impact. Total sorties flown exceeded 746,000 individual missions. Loss rate averaged 0.7% per sortie. Kill ratio reached 4.6 to 1 in P-47 favor. Bombs dropped totaled 32,000 tons. Ground targets destroyed exceeded 24,000 confirmed. The story of how the Luftwaffe never expected P-47s to carry half a B-17's bomb load illuminates a profound truth about military innovation throughout history. The Germans were acknowledged masters of specialized technical excellence. They completely failed to anticipate that Americans would systematically blur the traditional lines between fighter and bomber aircraft. The result was an aircraft that excelled not through perfection in one narrow role, but through genuine competence across all possible roles. The P-47 Thunderbolts' evolution from simple interceptor to devastating fighter-bomber didn't just surprise the Luftwaffe tactically. It revolutionized air warfare doctrine permanently. Every modern combat aircraft flying today incorporates fundamental lessons learned directly from the P-47's successful transformation. The heavy fighter that initially couldn't turn effectively with a nimble Messerschmitt became the aircraft that helped turn the tide of World War II decisively. In the final analysis, the 7-ton fighter that the Luftwaffe dismissed as hopelessly too heavy to matter became the primary instrument of their complete destruction. Not through superior performance in aerial combat, but through superior adaptability to changing battlefield reality. The P-47 proved conclusively that in modern warfare, the ultimate winner is not necessarily who flies the most specialized aircraft. The winner is who adapts fastest to rapidly changing tactical reality. The Luftwaffe never expected P-47 Thunderbolts to carry half a B-17's bomb load, because such capability violated their most fundamental understanding of air warfare principles. That critical failure of military imagination cost them air superiority over Europe. It cost them tactical mobility on the ground. It ultimately cost them the entire war. The P-47's transformation from fighter to fighter bomber remains history's clearest example of how tactical adaptation can achieve strategic revolution. It demonstrates how failure to recognize that revolution can doom even the most professional military force to absolutely devastating defeat.